Okay, today we'll talk about the observer pattern. So often we'd like to display data in more than one form at the same time. And when the data changes, we'd like to have all of the displays reflect those changes. So imagine stock prices were being shown in a bar graph, on a little ticker crawl at the bottom of the screen, and maybe in a table or a spreadsheet or something. When a stock price changes, we expect to see all of those visual representations change. So we have some stock here. It's got obviously a current price, but then we have different visual representations of that stock. So again, maybe a bar chart, maybe this ticker crawl at the bottom of the screen, and maybe just a really simple table of information. Okay, so the observer pattern assumes that the object containing the data is separate from the one displaying it. Okay. And when we implement observer, the data object is called the subject, and the display objects are called the observers. So however we're representing the stock price, that's the data that everybody is watching. And these guys over here, these are observers. And they're called observers because the displaying objects observe the changes in the data. And each of the observers is going to register its interest in the data, in the subject, by calling a method, which we'll find out shortly is called attach. Each observer then has a known interface that the subject will use to inform the observer when the data changes. So when the stock price changes, what the subject is going to do is going to go tell all the observers, hey, something about me has changed. You're going to need to update yourselves. So another example would be just a plain old spreadsheet. In a spreadsheet, when one cell changes, others may need to change too if the changing cell is part of a formula. And those changing cells might also be part of other formulas. This would create a cascade of changes that all have to happen automatically. Or that's the goal anyway with the observer pattern, is to have all of this stuff happen automatically. Okay, so if there's a graph representing the spreadsheet and the data changes, okay, the graph needs to change without the user asking the graph to refresh itself. That's the whole point of the observer. Okay, so let's just go over the pattern real quickly here. The intent is to define a one-to-many dependency between objects so that when one object changes state, and by changing state I mean that the data inside the object is altered in some way, all of its dependents are notified and updated automatically. So in this case, the one would be the stock object, and the many objects would be all the different types of displays that are displaying that one piece of data. Okay, this pattern has a few other names. So it's also known as publish subscribe, or pub/sub for short, and it's sometimes referred to MVC, model view controller. Okay, the motivation. So a common side effect of partitioning a system into cooperating classes is the need to maintain consistency between related objects. So when one changes, the others may need to be made aware of that so that they can react accordingly. You don't want to do this by tightly coupling classes. This reduces their reusability. So the cells in a spreadsheet are dependent on a changing cell, and the graph or whatever visual representation doesn't need to, all of the visual representations, they don't need to know about each other, but they have to behave as if they do. Okay, so all of the visual representations are dependent on the subject, but we really don't want them to have to know about each other. Okay, here's a class diagram of what the observer pattern looks like. And let me kind of explain this here. We start with this subject. Okay, the subject knows its observers by maintaining a collection of them. So the subject has an array list or some other kind of collection that holds references to the observer objects. So notice the little diamond here means that the subject has a list of observers. The observer provides a known interface for updating based on the subject changes. So this is a simple interface that the subject will call on the observers. And in fact, whenever the subject changes, that's when notify is called. And all notify does is it marches through the list of observers and calls update. That's the one method that belongs to the observer interface. Then we have this thing called a concrete subject. Sorry, concrete subject is over here. This stores the state information and participates in informing the observer when the state changes. So this is the object that will actually contain the data that the observers are interested in observing. And when the data changes, the concrete subject will call the inherited notify method, and the subject will then iterate through all the observers in the array list and call update on each observed object. Now the concrete observer over here maintains a reference to the concrete subject. So the observer has to be able to say, go back to the subject and say, well, give me your new state or give me your new data. Okay. The subject will call update on the observers, and the concrete observers will, like I said, go back to the subject and request the data that they are observing. Okay, so that's kind of what I said here about the subject, the observer, the concrete subject, and the concrete observer. Okay, the consequences of using this pattern. One can add new observers without changing the subject. Okay, or changing the class that holds the data. It's easy to add new types of observers, like new charts or new graphs, without changing the subject, without changing in this case, the stock class. There's minimal coupling between related classes. Coupling is what we call two classes that are dependent on each other. So if you change one and you must change the other, those two classes are coupled together. And in general, we want to minimize coupling between classes. Observer supports broadcast information. This should be used whenever you want to publish information to multiple subscribers. And again, we sometimes call this pub sub for publish subscribe. One thing to look out for, there might be an unexpected cost of update. So an update can cause an explosion of calls to observers. So be careful if you're communicating over a network to an extremely large number of observers, because the cost of doing these small changes might be overwhelming. Okay, so let's look at some code here. The first thing I want to do, though, is draw a class diagram and then compare it with the generic class diagram that we saw with the observer. Okay, so I'm going to start with the subject. And I'm going to do this a little bit differently. I'm going to make this subject an interface. Okay, and it's going to have basically three methods. Attach, detach, and notify. Okay. And then I'm going to have a subject impl. This is going to be an implementation of this interface. And I'm going to do this so that eventually we're going to have this class called myTime. and it's going to use the interface rather than the actual concrete implementation. That's just in case this MyTime class needs to extend some other class. We don't want to basically take the one opportunity to extend a class away from the actual subject. Okay, so we have subject and subject impl. Next we're going to have an interface called observer. Okay, it's just going to have a single method called update. And it turns out all of these classes are generic, and they can actually be used in any implementation of the observer pattern. Okay, next we have to actually talk about the application that I'm going to build. So I'm going to create this class called MyTime, and this just represents a time in a day. So there's an hour, minute, and a second. Okay, so this is what I want it to be the subject, and so there are going to be these displays that are looking at the MyTime, and anytime the time changes, all of the things that are watching or observing MyTime should change. Okay, so what we need to do here, if we want to make it a subject, MyTime is going to implement the subject interface, and then it's going to have a reference to an impl. Okay, so again, what this means is now MyTime can inherit from, if for some reason it has to inherit from some other class, we haven't just taken away the one chance to inherit from MyTime. Okay, then we are going to have a couple of observers. We're going to have one called command line time. This is going to be an observer. Okay, so it's going to implement this interface. Okay, and we're going to have another one called JFrame time. Okay, so both of these implement this interface. Both of them must provide a method, an implementation for this method called update. Now I said concrete observers always have a reference back to the subject. Okay, so these guys are going to store a reference to MyTime. Okay, so let's just kind of quickly compare our two pictures. This was the generic picture here that we had the subject. Actually, I forgot a really important part here. The subject, let's consider this whole thing the subject, has a list of observers. The observers, we have the concrete observers. All the concrete observers have a link back to the concrete subject, which is MyTime. Okay. So again, this guy here, this would be the MyTime, and over here we would have multiple observers, command line time and JFrame time. Okay, now let's look at some code. Okay, so we said we're going to start with this subject interface, which has three methods: attach, detach, and notify. Now notify is actually a method in the object class, so I changed the name here to notify all observers. Okay, but it's just a simple interface here. Attach is how an observer is going to register its interest in the data. Detach then is how an observer says he's no longer interested in looking at the data. And then notify all observers. This is going to be called by the concrete subject whenever the data changes. Okay, whenever all the observers need to be notified, the concrete subject will call this notify all observers. Now the subject impl, we said, is going to implement subject. Okay. And again, we're doing this so that concrete subjects can extend or inherit from some other class, not just the subject class itself. So the subject impl has a list of observers, which it calls observers. So in the constructor, we make the empty list. In attach, okay, attach is always called with a reference to an observer. So this will be like a command line time or a JFrame time. They're going to pass references to themselves to this attach method, and the subject impl is just going to add those observers to the list. Detach, this is how you remove from a list. And then finally, notify all observers. You remember, you're just going to walk through all the observers and call update on each one. And that's exactly what we do. We just have the simple for loop, and we know each observer has this method called update. Okay, and then it'll be up to the concrete observers to actually go back to the time object and get the new data. Okay, our observer interface again is very simple, just a single method called update. And this is the concrete subject. So it's called myTime. It implements the subject interface. It has 3 integers, one for the hour, minute, and second. And then it has this flag that says whether the clock is started or not. This will make sense in a second when I run it. The myTime also has a reference to a subject impl. Okay, so this is an implementation of the subject interface. Okay, and basically what this class is going to do is delegate all subject methods to the impl. So attach, detach, and notify observers, it'll just use the impl to call attach, detach, and notify all observers. Okay, and again, we do this so that myTime, it doesn't happen to be extending anything else right now, but if myTime needed to extend some other class, well, it could still be a subject. Of course, in Java, though, you can only extend one class. So that's the whole point of having a subject interface and a subject impl. Now, the constructor for the myTime, it will create the subject impl, set the time to some standard time, and set the clock started equal to false. Now to increment the time, we'll do something like this. If increment will increase the time by 1 second. So if it happens to, or if it's not the last second, we'll just add 1. Otherwise, we have to wrap around, and it might be the last minute. We'd have to wrap around there. It might be the last hour. We'd have to wrap around there. Okay, the most important part of this increment method is at the bottom. Whenever the time is incremented by 1 second, we are going to notify all the observers. Remember, this is the method that comes from the subject interface. And we're just going to offload that functionality to the subject impl, which, remember, just marches through the list of observers and calls update. Then getTime basically just gets a string representation of the time. Nothing terribly exciting there. And we have a bunch of getters and setters. Again, nothing terribly exciting. Next, we'll look at the driver. Okay, so here's our one and only time object. Okay, and we're going to set the time to 6:30 a.m. We're going to say that the clock has started. Okay, now here we're going to create some observers. So we have this command line time observer, which we always pass the observer the subject or the piece of data that it's watching. And then I'm going to create 4 JFrames, which are GUI observers. So you'll see in a second the command line time is going to show the time on the command line, whereas the JFrames will have these GUI widgets to show the time. Okay, and then basically what's going to happen is once a second from the driver, we're going to increment the time and then basically go to sleep for 1,000 milliseconds or a second. And this loop, we're going to, the time is going to be incremented, the one and only time object will be incremented, and then what we should see is all the observers will be notified of this change, and they will go and grab the new time. So before I show you the observers, let me run the program. Okay, so here are my 4 GUI observers, and you'll notice they're each displaying a time. Okay, and then here's my command line time. It is also kind of observing the one and only time object. Now each one of these GUIs we can change the time by putting new values in here and clicking the button. And again, what you'll see is all the observers, they saw that one change, and the driver again is incrementing the time once a second. Okay, and we should see the wraparound to the next day. Okay, so we have 5 observers observing one and only one time object. And every time the time object changes, we notify all the observers and they go grab the new time and display them. Okay, so let's now look at the concrete observers. We had the command line time, which is down here. Command line time implements observer. So that's the contract that's saying it's going to provide a method called update, which it does down here. And in fact, all it does is it goes to the time reference and gets the new time. Okay, so when you create a command line time, we pass in a reference to the one and only myTime object. And again, when we say time is equal to MT, this object's myTime reference now points to the one that gets passed in. So remember, in the driver, when we create a command line time, we pass in a reference to the time. When we create these 4 JFrame times, we pass in a reference to the one and only time. Okay, and again, when the subject does update the observer, we just go using that myTime reference, we go and get the new time and print it out on the screen. Now the JFrame time is a little more complicated. It extends JFrame, it implements observer and action listener. Okay. It also has a reference to the one and only myTime object, which gets passed into the constructor. Okay, we store a reference to that because we're going to need it later. And we also need to attach. So I think I forgot that part here. The command line time, it must call attach to register its interest. So time is the subject, and we're saying to the subject object, I am now interested in any changes to you. Okay. The same is true of this observer. Not only do observers store a reference to the subject, they must attach themselves to the subject. We could, of course, detach in the future. I don't happen to do that in this program, but if an observer is no longer interested, it can detach itself. The rest of this is just setting up the GUI. There's an action performed. If you do want to change the time, you can just get the hour, minute, and second from the text box to the text boxes, and then update, it just goes to that label and sets the time to the one and only time objects get time method. Okay, so that's the observer. And again, this is really useful whenever you are going to have multiple objects that need to know about when a piece of data changes so that they can react to it. So the examples I gave were all kind of GUI based or graphical based, but it doesn't have to be purely graphical. Anytime you want to publish some data and you have these subscribers who are interested in it, that's when you would use Observer.